some idioms. We actually saw some of these earlier. These are conventional ways that experienced programmers put together pieces of code that have come to be conventions. And variations from these suggest dangers or significant differences which require attention. So adhering to the idioms lowers everyone's risk of confusion, lowers the cognitive overhead needed to understand the code. Okay? So here's an example of a looping. And these are three different ways to express looping. So this is actually on its way to looping. So we can use while, and we can have a while loop which starts at 0, I starts at 0, and each body of the loop in increments I, all the way up to n minus 1, and it writes to an array. N is the number of elements in the array. Okay? Another alternative would be to do it this way, with a for loop. And here we have each successive iteration of the loop initialize an element of the array and it increments on. Yet another way we could do it would be to go from the upper bound, n, that's the upper limit actually, to only continue if I pre-decrementing. In other words, we're going to compare we're going to lower the value of I before comparing it, and then we assign to the array. These all do the same thing, ladies and gentlemen. All do the same thing. And it confronts us with the fact that in general, there's an unlimited number of different, well, I shouldn't say unlimited, of extremely large number of different ways we can accomplish a given task. However, each of these is non-standard. You could write it, you might understand it, but if you showed your code to someone who does professional C development, they'd say, oh, that's kind of weird. Why are you doing it that way? How kind of should you do it by C convention? Can anyone volunteer? Good. So you have a for loop. This is the sort of situation for which for loops were designed. Yeah, for loop with some initialization for I equals 0. Rather than putting it before, a while loop up there, putting it before for loop, put it in the for loop. That's what these were built for. No pun intended. So for I equals 0, and then I is less than n. Actually, that's standard. So you do I is less than n, not less than or equal to n minus 1. That's just confusing. You do I is less than n. You know it will never get to n by seeing that. And then you do what in the final? Updates of I plus plus. And then in the body of the loop, you have array of I equals 1. It's a familiar form, immediately recognizable to an experienced C programmer, and there's fewer things going on in the body, so you can more clearly understand what's going on in the body. So that, ladies and gentlemen, would be a more conventional way to do it. In other words, this. Okay? Now, one of the reasons for these idioms, for these conventions, is to lower cognitive overhead, but also to be able to recognize problems. So, ladies and gentlemen, here we have, oh man, you shouldn't be called by array. I don't know what's going on here. Sorry. This should not be called an I array. It should be an array of integers. And in fact, we'll do it just so you could see it. We could do, P array. Okay, if you want to have it be a pointer, then that's fine. And then we update it that way. That's actually fine. But don't do it with I array. That's just, it's like treating it. It suggests an A suggests it's an index. Okay. So here we have a pointer to some array. The array is allocated. What's the size of this array? Well, this is the size of each element. So malloc allocates things with a certain amount of bytes. So to determine the number of bytes, you multiply the size of each thing in that array times the number of elements of the array, which is called nmem. Oh, yeah. Fine. We'll do that for now. And here we have this for loop. Now, what's not idiomatic about this? Why is this for loop non-standard? if this less than or equal to, what would that lead to happen? Yeah, it will cause a problem because it will iterate through up to the point where it actually assigns within the array to an element which hasn't been allocated. In other words, an element just beyond the end of the array. The array has n memb elements. Imagine if n memb is 1. Then we should only be assigning to an element at index what? 0. And instead, we'll be starting at 0. We're going to say, okay, is I less than or equal to, in other words, is I less than or equal to 1? And yes, it's less than or equal to 1. Okay, so run the body. We'll say, okay, I is 0 here, assign to element 0, the value of I. Assign 0 to the first element. And then it goes up again, and it says, okay, I is now incremented, so I is now 1. Is I, in 1, less than or equal to 1? Yeah, it's less than or equal to. Now we'll assign to number 1 in that array. Index 1 in that array. The array is a blank 1, so it only has an element at index 0. And now we've assigned to index 0 and index 1. Ladies and gentlemen, things like this may seem quaint, but you have problems like this all the time as you go. Off by 1 errors. There are a whole class of it. I'm just going to draw blood legend because I can immediately spot these sort of things as a software engineer. So I mean, this is one of the reasons we have these conventions. What's not idiomatic about it is that we have less than or equal. It should be less than. And we'll spot it. This is a sign that, okay, something funny may be going on. You don't want to be have your code scrutinized just because you're not idiomatic how you use C. You want to sort of adhere to these conventions, not flaunt your ability to do it in some weird ways. There's plenty of weird ways you can do things in C. Trying to show off because that is just a rookie thing. So here, we can spot that more or less immediately because we have idioms. We can spot the logical error associated with this, okay? So the loop goes 1, error 2, fine. So here's a infinite loop idiom. So these are 3 different common ways of writing that. This is called a forever loop sometimes. So you just have a loop that goes on forever. Why do we have a loop that just goes on forever? Well, there's no control to stop it. When would you ever have that? Sorry? Yeah. So if you have user interfaces, for example, if you have something which is taking commands from the command prompt. Now, inside that loop, there may be something that says return, or something that says break, or something like that. But the loop itself is not set up to only go for a finite duration. Another thing you can have is while 1 in classic C, or while true in C++. These are all sort of familiar constructs. And I would note that you could do while capital true as a macro in C. Okay, so those are some loop idioms. Let me just stop